In this recording, we're going to start to talk about characteristics of polynomial functions. As these polynomial functions get more complicated, it becomes difficult sometimes to find key values algebraically. So we're going to first go over how to use the graphing calculator to get a nice sketch of the function, including a good window, and also how to find intercepts and relative extrema. Now that's just a fancy word for the turning points. It's a more general word. They could be maximum or minimum points. So when we talk about relative extrema, other words would be local max or min, or you could talk about relative max or min. So those are all saying the same thing. The turning point, local max or min, relative max or min, etc. Vertex refers specifically to a max or min of a parabola. So once we get into polynomials where the function might look like this or something, or maybe a sort of a W shape or something like that, then we don't have just one maximum or minimum, so we call it relative extrema. So let's get in and look at this graph. Alright, so we'll head over to the graphing calculator. We'll enter this function. Alright, and a good thing to do at this point is just to double check that you have entered that correctly. Make sure everything is perfect, otherwise we'll get different answers. So it looks like I have it correctly. So now we're going to figure out what our graphing window could look like. Now you might just hit zoom 6 and look at what it is. That'll give you an idea, but it won't always appear in there. So the question is, alright, how do I adjust this window if I can't see the whole function? Or how much of the function am I expecting to see? Well, it's a cubic, right? It's the third power. So we know it could have up to 3 x-intercepts. You could have 2 turning points. I think the best way to be certain about it is to peek at your table. So when you look at your table, you're looking for places where the y value changes from positive to negative. So I'm looking right in here. So I'm pretty sure that there's 1, 0 in between -3 and -2. And let's see, I see another place where it changes from positive to negative here. So between -1 and 0, there's going to be another x-intercept. And then it goes below the x-axis, and then it pops up above the x-axis and stays up. So I'm seeing zeros between 1 and 2 as well. So I think if I make my x-axis anywhere between -3 and +3, that should cover the x-intercepts. And then in terms of how big the y should be, well, in between where the x-intercepts are, okay, how high does it get? So like in here, well, it got up to 10, maybe a little bigger. In here, maybe it got down to like -10, maybe a little bigger. So I'm just going to start with this. It's a little bit of a trial and error, but I'm going to start with -3 to 3 for the x's, because we said that. We think our x-intercepts are in between there. And for the y's, I'm going to go like -20 to 20. I think that will be reasonable. And I can adjust it later if it's not. -20 to 20 in the y. Don't worry too much about the scaling or the resolution. You can just leave those things as they are. Now just hit graph. What I'm looking to see is, do I see the turning points? Yes. Do I see the intercepts that I'm expecting to have? It's a cubic, so I could expect at most 3 x-intercepts and at most 2 turning points or relative extrema. So I'm pretty happy with that. So let me sketch that graph and let me identify the windows. So we'll get that put into our note. Okay, so I'm just going to make a sketch here based on kind of modeling for you what you should do. So make your axes. And then sketch that function. Alright, now we want to label. and say that this was between 3 and negative 3. And 20 and negative 20 in the y's. Okay, so now I've got a sense of our window range, and now we just want to find some key values. I'll identify the points we want to find. That turning point and that turning point's coordinates, that x-intercept and that x-intercept and that x-intercept. We can find the y-intercept pretty easily, right? That's just the constant of the function. So I can just go ahead and put that in there. That's not going to be difficult for me to find. I'm not even going to write that in there. I'm not even going to clutter the diagram with that. But that's all the stuff we need right now. Okay, so let's use those tools on the calculator to find out that bit of information. Okay, so first off is we're going to find the x-intercept here. So we're going to hit second, calc, and that is a 0. That's what the calculator calls it, a 0, because it's the x value that makes a y value 0. Okay, so we're going to bring our cursor to the left. It's asking me a question here. What's the left bound of this point that you're finding? Because it doesn't know which one I'm talking about, right? There are 3 here. So I have to move my cursor to the left of that point. Anywhere to the left will do, and then hit enter. And now, right bound. So move your cursor to the right of that point. I don't need to go quite that far. I can just be like right there, right? Hit enter. So it's saying that x-intercept is somewhere between the 2 dotted lines. And then a guess. Well, anywhere close will do. All right, it's good enough. And so it's telling me there is a 0, an x-intercept, a root. Those are all saying the same thing at negative 2. So let's put that on our sketch here. Okay, I'll try to be consistent writing the x and the y of each point. All right, let's proceed. I want to find this point here. Now, that point is called a maximum. If you're an ant crawling on this, you think you've reached the top of the mountain, even though you don't realize that over here the graph actually gets higher. To you, that's a maximum. It's a relative maximum. Okay, that's what we call it. So go ahead and find that maximum. We're going to hit second calc. Every time second calc, but this time I want the maximum tool, so choice 4. And I need to be the left of that point. And now it's saying right bound, to be to the right of that point. And hit enter. And now a guess. Okay. So it's telling me the maximum, I'm going to round this to the 100th, is negative 1.29 and 11.37. Okay, so we have that point's coordinates. I want you to proceed to find the rest of those points. You're going to find the 0 again here. You're going to find the minimum point here, and you're going to find the 0 there. And play the recording when you're ready. Okay, so I'll just kind of show the process for it, and you can check your answers or just fast forward and see it. Or if you need help, you can watch. So first I'm going to find that 0 right there. Okay, so that 0 is at negative 0.33, or 1/3. All right, now I'm going to find that minimum point right there. Okay, so it found my coordinates at 0.73 and negative 13.41. Finally, I want to find that 0 right there. And the 0's at 1.5. All right, now we have it. Looking back at the directions, it does say find all the intercepts, and so it looks like we have not found the y-intercept here, but that's easy, right? That's when x is 0, so we can just sub in a 0 for x, and we get the -6. So when we sub in 0, when this is in standard form, we get 0, -6. We didn't need the calculator for that. Thanks for watching.